secured circuit layer. So how SSL works அப்படிங்கறத பத்தி நம்ம டிஸ்கஸ் பண்ணலாம். So before that, internet security is a great importance to nowadays. Now we are living in a digital era. So we are implementing various security services, existing services for email, electronic transactions and electronic payments. So internet security is the greatest important one nowadays. So the famous internet security protocol is secure socket layer. So secure socket layer is the internet protocol. It's mainly used for exchanging the information between the web browser and the web server. So it provides mainly two services. One is authentication, another one is confidentiality. So logically it makes a virtual connection between the web browser and the web client. So initially it was developed by Netscape Corporation in 1994 and it is a famous protocol for implementing web security. So now we have the question is, so internet is working on based on the TCP/IP protocol. So TCP/IP protocol relays the backbone of your internet. So where the security socket layer is implemented in TCP/IP protocol shoot. So already you know that the TCP/IP protocol has 5 layers: physical, data link, internet, transport and application layer. So now SSL is implemented between the application layer and the transport layer. So SSL layer, so normally we send the sender sends the message from the application level. So the center of the computer sends the data from the application layer. The application data is transferred not directly to transport layer. Instead, it is transferred to SSL layer. SSL layer is transfer agum. So SSL layer receives the application data and it performs the encryption over the data and it adds its own header, like it is called as secure socket header. So now you have the question is, why we place the secure socket layer in between application and transport? Because SSL only encrypts the application layer data. So why we are placed here? So why that we have not placed SSL below the data link layers? So from the working of SSL, it only encrypts the data. So if it is placed below the data link layer, it encrypts all the header, that is application layer, transport header and internet header and data link headers. So it already transfers the IP addresses and physical addresses of the receiver's computer. So it is unreadable format and it's unknown format. This is the problem arises when we are putting the SSL layer below the data link layer. So SSL layer works or it encrypts only the application data. So now next we are going to discuss about how SSL works. So SSL has 3 sub-layers, namely Handshake protocol, record protocol and alert protocol. So first we are going to discuss about Handshake protocol. Handshake protocol, like if you are met your friend, you just say a hello. So like that, the Handshake protocol works like a normal hello message. So like between two parties wants to communicate between them, each of them they say hello only. So the format of the Handshake protocol is the type and length and content. The type consists 1 byte and length belongs to 3 bytes and content it contains 1 or more byte. The type defines several messages. The SSL layer, the protocol accepts the messages. So we are discussing next the phases of Handshake protocol. The Handshake protocol consists of 4 phases. The first one is establish the security capabilities. The second one is server authentication and key exchange. The third one is client authentication and key exchange. And the fourth one is finish the handshaking method. So the first phase, the establishing the security capabilities. So normally the type consists 10 message already I said. Now what are the messages means? First one is a hello request. So if you are seeing your friend, so you can make a smile, then it is known as a hello request. Then the second type of message is client hello, server hello, and the fourth one is server certificate, server key exchange and certificate request, the server hello done. Similarly from the client side, certificate, client key exchange and certification verify. The last one is Cipher protocol send and then accept the messages. So in the first phase of the handshake protocol is establish the security capabilities. It is nothing but normally we are saying the hello, but when our friends, when we are meeting with our friends, like that the sender and the server wants to communicate with the initial hello. So the web browser sends the client hello message to web server. The client hello message having several parameters. The first one is the version. It defines the highest version of SSL. The second one is a random number. It is used in actual communication. The third one is the session ID. The session ID, it's a variable length identifier. If it is a non-zero, we assume that the client has already a connection between the server. If it is zero, the client wants to establish a new connection to the server. The next one is a cipher suit mechanisms. That is, the client accepts the algorithms, cipher spec algorithms like DES, RSA, IDEA or AES. The last one is a random number. Similarly, once the client has issued the client hello message, the server responds back by issuing the server hello message. So server hello message also consists the same parameters such that version, random ID and the cipher spec algorithms and the session ID algorithms. The second phase of once the initial hello will established between the client and the server, the second step is server authentication and key exchange. It will be established only by the server. The web server sends all the messages to the web browser to initiate the connections. So first it sends the certificate message to web browser. The certificate consists the web server digital certificate. It will be tied up with the root CA and it enables the client to verify the server's certificate, server's digital certificate. The second message is server key exchange. If the server didn't send a certificate to a web browser, then it will send the server key exchange. It consists of the server's public key. The third message is certificate request. So the server demanded a client's digital certificate for continuing the connections. The fourth one is server hello done. So once all these steps are done, the web server finishes the messages, the entire hello will be finished, completed. So this is the second phase. So server authentication. So it is mainly for server authentication. The third step of the handshake protocol is client authentication and key exchange. So in this, the sole property is done by the web client. So it sends all the messages to web server. That is, once the server sends the messages, the client responds back. So by sending the message, the first one is certificate, the second one is client key exchange, the third one is certificate verify. So in the first message, certificate, the client sends the certificate to the server only if the server requested the digital certificate from the client. The second one is client key exchange. So if the client didn't want to perform the communication, then it sends the no certificate message to the web server. That is, I didn't want to communicate with you. The second message is client key exchange. So in this, the client sends the private key. That is, it sends the message to the server by encrypting the server's public key. So it is a 48-bit message, and the third one is the certificate verify. It is done by the web server. That is, the client is a corresponding authority to make a communication. The fourth phase of the SSL handshake protocol is finished. So the client initiate this phase by sending change cipher specs message and finish the message. So the server responds back by sending again change cipher specs and finish. So in this phase, the client uses the pre-master secret. Already I have said that it is created in third step. It sends a message by encrypt a message by server's public key, and it is about 48 byte field. It is known as pre-master secret. So the client uses the pre-master secret, and both the client and the server uses random number, and it uses the MD5 algorithms. It generates the master secret before sending the actual communication. Similarly, it sends the symmetry key also. It's a symmetry key generation. So similarly, it generates a symmetry key performations. So once the handshake protocol sends the find out the initial master secret and the symmetry key. Then the record protocol, the second phase of the SSL protocol is record protocol. So it belongs to the actual communication is overdone between the sender and the receiver. So it also ensures two security services. One is in confidentiality, another one is in integrity. So the record protocol, it receives the message and it divides the message into group of small blocks known as the fragmentation, and it compresses the block by using some compression schemes, and it adds the M.C.A. It is created in the handshake protocol phase, and the fourth step is it encrypts the original message. So similarly, the record protocol adds the append header, like it adds the headers such as the content type, major version and minor version, and compressed length. So type specifies the SSL version, types belong to the specified type, and the major version is SSL3 and minor version is SSL0, and the length of the header. So all those information is header field is added to the plain text, and it also encrypted. So it is done only in the record protocol, and the last protocol is named as alert protocol. So when the communication is overcoming between the sender and the receiver, if both of them face some errors, that is if both of them mismatch, then error is occurred. So alert protocol contains two bytes. The first byte specifies the type of the error. The second byte specifies the actual error. The type of the error, if it is a warning, the field contains 1. If it is a fatal, the field contains 2. So when the error is occurred, the client and server both end the connections, and it closes the master secret, and it closes the symmetric key secret, and it ends all the session IDs between the client and the server. So this way how the SSL secure circuit layer is worked. So thank you.